Let's learn about parallel and perpendicular lines. We're going to review equations of lines, and then we'll get into equations of parallel and perpendicular lines, and we're going to be graphing each. Let's get ready. You're going to need notes and a pencil. And just for a review, here we have slope-intercept form. It's exactly what the title says. So remember, our m is our slope. It's not attached to the x. That just means multiplication. X is just x of our point. And then b is our y-intercept, where it crosses the y-axis. So when we were to graph something like y equals 2/3 x minus 3, we want to start with that y-intercept. And remember, this is the x-axis and this is the y-axis. So if I'm going to -3, I'm right here at -3. I'm down on the y-axis. Then you want to move your slope. And in this case, we have a slope of 2/3, which means I'm going to go up 2 to the right 3. So from my y-intercept, I'm going to go up 2 to the right 3, and I'm going to put a point. I could go up 2 to the right 3 and put another point. Draw my line and put your arrowheads on to show that it goes on forever. Here we're going to graph. I have a y-intercept of +4, so I'm up on my y-axis. And I have a slope that's negative. So remember, a negative slope is going to fall left to right. So in this case, with -1/2, I put the negative up there. So I'm going to go down 1 to the right 2 from my y-intercept. So I'm going to go down 1 to the right 2 and put a point, down 1 to the right 2 and put a point. And that's how we're graphing our lines. So if we go back to the first one that we did, and now if I ask you to graph a line parallel to this, we've been drawing parallel lines in space. Now we're drawing parallel lines on a coordinate plane. So we noticed that we had the slope of 2/3. So I'm just going to go like this, 2 and 3. That's my movement, up 2 to the right 3. So if I was just sketching it, I could go something like that, but we need to be a little more particular with it. So I happen to go through a y-intercept of 1. And let's see if I moved up 2 to the right 3, and I have another point, and those lines look parallel. So that's one line that would be parallel. It has the same slope of 2/3 with the x, and then a y-intercept of 1. So this equation is a line that's parallel to that. I could have another one up here. Oops, it's supposed to go through there. As long as they are slanted, oops, that one's not about the same because that's going to intersect. As long as they are slanted the same amount, that slanting piece is the slope. So that's what we're paying attention to here. So if I have this line and we graphed this at 4 and then we went down 1/2 and we have that, then I can pick any number I want for my y-intercept. I'm going to go with -2. And then I'm going to move the same slope down 1/2, and those lines would be parallel. The equation of that line is y equals -1/2 x for the same slope minus 2 for my y-intercept. So parallel lines are going to have the same slope but different y-intercepts. Notice same slope, but they cross y at different places there. Same slope, +2/3, different y-intercept. Now let's take a look at perpendicular. And remember that perpendicular means intersects at a 90-degree angle. We could have it diagonally kind of as well. So we'll start with graphing this one. I'm going to plot the y-intercept at -1, and I'm going to move my slope up 2/1, up 2/1, and I have that, oops, that line right there. Ignore that piece. So this is kind of like this. So it's going to go diagonally the other way. So I went up 2/1, and if I go down 2/1, back 2/1, then we're going to have a line like that. So notice that the first line I drew had a positive slope. The second line I drew had a negative slope. That's an important piece. Also, they are going to have different y-intercepts. So we just mentioned that perpendicular lines are going to have opposite slopes, but that's not all. There's something else that has to happen. So if I graph my first one with -1 up 2 over 1, and then I tell you that this line is perpendicular to it. So this has a y-intercept of 3, and it's going to go down 1 to the right 2 like that, and it will be perpendicular. And I can put a little right angle box on there. So now if you see this first slope is positive, the second slope is negative, but how do the numbers themselves compare? How is 2 compared to 1/2? Well, this slope of 2 is really 2 over 1. Well, you have a whole number, it's over a 1. And then this one is 1 over 2. Those are called reciprocals. So with perpendicular lines, you're going to have opposite slopes and reciprocal slopes. So we call that opposite reciprocal. It's 2 words, so it means you're doing 2 things. The signs, I guess I should circle that one. The signs have to be opposite and the numbers have to be reciprocal. So 2 and 1/2, those are reciprocals. 2/3 and 3/2 are reciprocals. 1/4 and 4, those are reciprocals. You flip the fraction. So to recap, parallel lines will have the same slope but a different y-intercept. Perpendicular lines will have opposite reciprocal slopes. Nice job.